Hello friends, welcome to another session. So today we are going to solve another round of number system problem. So we did a number system problem solving session 1 where we have talked about the normal divisibility rules and some other type of problems we have solved. Before that, if you are already aware, we did around 7 to 8 sessions on number system, focusing specifically on different concept blocks of number system. I'll put all of that in the description box. Please go through it. And today we are going to solve another type of problem solving session on number system. So this will be the problem session 2 on number system. So without further ado, let's get started. Just a minute. So if you can see the problem, it says the first problem for today, it says the LCM of 32 and 80 and x is 1120. So we can say LCM of 32, 80 and x is 1120. And then they said their HCF is 8. So HCF of 32, 80 and x is equal to 8. What is the small difference between the smallest and the largest value of x? So first, then I need to understand what are the possible values of x, or how we can find the smallest and the largest value. So to do that, let's break all of this into factors and see how we can get 1120 or 8. So if I break 32, I get normally 2 to the power 5. Okay. If I break 80, I'll get 2 to the power 4 into 5. Similarly, if I break 1120, I'll get 2 cube. Let me do 1120 by 8. So you'll get 8 gives 96. So 8, 12, 96, 16. Okay, 8 12s are 96, 8 is 1. So this is 14, 8, 14 and 0, 140. So we'll further divide by 2. So okay, just a minute. So you will get 14. Yeah, so this is 140. And then if you further divide by 2, you will get 70. You further divide by 2, you will get 35. 5 into 7. Okay. So you get 2 to the power 5. You get, okay, if I do this, you'll get so you'll get 2 to the power 5, which is basically, if you do here 70, so you'll get 235, and then you do again with 5, you will get 7. So 8 into 2 into 2, which is 8 is 2 cube, and then another 2 more 2, so you'll get 2 to the power 5. 2 to the power 5 into 5 into 7. Okay, now the HCF is 8. 8 means 2 cube. So what I know from HCF is basically HCF is the max value of the max power of the common variable which is present in all the cases. So in 32 we have 2 to the power 5, in 80 we have 2 to the power 4, but then in x, then in along with this 2, then in x I cannot have more than 2 to the power 3, because if I have as a power of 2, I cannot have more than 2 to the power 3, because to satisfy the HCF to be 8, my highest power of 2 can only be 3, which is common in all the three values. By three values I mean 32, 82 and 32, 80 and x. So out of these three values, I cannot have more than the power of 3 for 2. So that's what, because if it is more than power of 3, it will be either 4 or 5, and HCF is not anymore 8. So HCF will be either 2 to the power 4 or 2 to the power 5. So x can have highest value of 2 as 2 cube, right? Now that not the only possibility, because for 2 it will be the highest power. Okay. Now for 1120, now if I see for 1120, it will have a 7 and it will have a 5. No, so HCF criteria satisfied if x is 2 cube. But for LCM to be 1120, x has to have at least 1 7. For LCM, what we know, it will take all the variables that are present in any one of the three. It will take all the variables that is present in any one of the three and the highest power of each of the variable. So highest power of each of the variables, so 2 to the power 5 is already taken here. 5 here is already taken here. So 7 is not present anywhere. So the 7 has to be here. Otherwise, there is no 7 in 32, 80 and x. So 1120 from where it will get 7. So for 7 to come in 1120, I have to have 7 in x. So this is the minimum possible value because 5 I may put, may not put because 5 in 1120 is anyway coming from 80. 2 to the power 5 in 1120 anyway coming from 32 because 32 has the highest power of 2 as of now, and 7. So this is basically 56. Okay, so this is the smallest value because you had to give 7 to x. And what is the other value of x possible? X will have 2 cube and 7 for sure. X cannot have more than 2 cube uh, for satisfying the HCF, and x has to have 7 only. If it is higher values of 7 is also not possible, then this 1120 will have a higher value of 7 because we know it will take all the values that is present in any one of them and take the highest factor, highest power of that variable in any one of them. So 2 out of all the 3, 32, 80 and x, highest power is 5. That is coming in 1120. 5, the highest power can max be 5. 5 to the power 1. That's why it is only 5. 7 also highest power can only be 7 to the power 1. That's why 1120 has 7 to the power 1. If I put 7 or 7 square of 7 cube, 1120 will have the same. Then it will not be 1120. So that's why when I talk about the largest values of x, it will have 2 cube and 7 only, but it can also have 5 because if it has 5, 1120 can also get 5. So a 5 may not be only in 85, may be in x also. So that's an optional thing for x because if 80 also has 5, x also has 5, 1120 can get only 1 5. So it will not breaching the contract of 1120, but I can optionally add 5 with x. So now this becomes 280. So 280 is the largest. So the difference is 280 minus 56 or 214. Sorry, 224. So 224 is the difference. Okay. So hope you understood concepts. Slowly saying how from the factors you can find out the LCM and HCM and how using that concept we were able to derive the largest and the smallest value of a number. And hope you understand this. If you have understood this clearly, if any doubt, please feel free to drop a note in the comment section. We'll be able to help you from there, or you can mail me with the mail ID given in the description box. So let's go to the next problem. The next problem says a natural number n when divided by 27 leaves a remainder of 10. Okay, so can I write n as 27k plus 10? Okay, 27k plus 10. So in first case, if it is divided by 9, so n divided by 9, so that means 27k plus 10 divided by 9. So 27k divided by 9 plus 10 divided by 9. So if I have to talk about the remainder, of these two scenarios, so the remainder in first case will always be 0 because something multiple of 27 is by default multiple of 9. Any number that is multiple of 27 will be multiple of 9. So the remainder will be 0. In the second case, 10 when divided by 9 gives a remainder of so this will be 10 by 9 and the remainder will be 0 plus 1 and 1 is the remainder always. So something which is divided by 27 and leaves a remainder of 10. When divided by 9, it will give a remainder of 1. Now in the second case, it says 54. Okay. So n divided by 54, or I said 27k divided plus 10 divided by 54. Okay. 7k plus 10 divided by 54. So now we can again further break it down. 27k by 54 plus you have the remainder of 10 by 54. So in the second case, it will always be 10. In the first case, think on this 27k. 27k. When I say k equal to 1, your value is 27. K equal to 2, your value is 54. K equal to 3, your value is 81. K equal to 4, your value is 108. So what I'm trying to tell you is, with all the even values of k, it will be a multiple of 54 only. This is 108. Because 27 into 2 is 54. So 27 into 4 will be divided by 54, because 27 into 2 will be present in that. So all the even values of k, it will be divisible by 54. But for the odd values of k, it will have a remainder of 27, because 27 into 1, 27. When divided by 54, the remainder is 27. 27 into 3, 81. Again, 27 is as a remainder when 81 is divided by 54. So it will have 0. Can I write? It will have 0 or 27 as a remainder. 0 when k is even. So basically 0 when k is even. 27 when k is odd. These are the only two possible remainder that can have come out when a multiple of 27 is divided by 54. Okay. So your final remainder is either 10 or 37. So 0 plus 10 is 10, 27 plus 10 is 37. So this is your answer. Clear? Okay, let's move to the next problem. Says a two-digit number when divided by 10, 12, and 15 leaves a remainder of 7 in each case. Okay. 10, 12, and 15 leaves a remainder of 7 in each case. So you know, basically, again, go back to the concept sessions, what we have told. When a number getting divided by P, Q, R leaves the same remainder, K, then the number can be written as n. So let's say the number is n. N is LCM of P, Q, R plus K. Okay. LCM of P, Q, R plus K, that's the first iteration of the number. If you want to do the higher variation of the number, then you can read this as LCM of P, Q, R into n plus K, small n. What is small n signifies? Small n signifies the higher values of that number. So the lowest value of that number is LCM of P, Q, R plus K, where n is 1. The higher values of those number is basically LCM of P, Q, R into n plus K. So in this case, what we did is, here we have to do LCM of 10, 12, and 15. 10, 12, and 15 plus they are looking for the least such number. So least such number, so then n can be equal to 1 in this case. We're talking about the least such number. So n can be 1 in this case. So plus 7. What is the common remainder? That is 7. Okay. So 10, 12, and 15. What is the LCM? LCM is 60 plus 7, 67. So the least such number is 67. When 67 divided by 36, you have a remainder of 31. Okay, so 31 is your answer. Okay, what will be the, for your understanding, again repeating, what will be the higher such values of n? So the next set of values of n will be ideally 60n plus 7. In our case, n was 1, so that's why 60 plus 7. The other next value of n will be 60 into 2 plus 7. Then the next value is 60 into 3 plus 7, and so on. So all these values you will see satisfies the criteria 10, 12, and 15. When divided by 10, 12, and 15, those numbers will give a remainder of 7. All these values. Okay. So in this case, our answer is 31. Okay. Let's move to the next problem. A number when divided by 18 and 24 leaves a remainder of 14 and 20. Okay. So in this case, when we say when you divide by 18 gives a remainder of 14, when you divide by 24 gives a remainder of 20. So here also the gap is 4, here also the gap is 4. So this kind of problem we said, again go back to the division of the number remainder formulas when we talk about this how to find a number based on this division rule in the number system concepts. What we told, again I'm just writing this: if a number is divided by PQ and gives different remainder, where the difference of remainders from P and Q always same, then the number minus LCM of PQ minus the difference. So in this case, again, this is something we are repeating. We kind of explained this earlier, but again, just for your refresher, we just note this. So here, 18 and 24 are your P and Q, and respective remainder 14 and 20. So that we can see the difference is constant. The difference of remainder from the divisor. So 18 and 24 is basically giving you 14 and 18 and 24 gives you 14 and 20. So both the cases, the gap is 4. So here your number will be LCM of 18 and 24 minus 4. So LCM of 18 and 24. So what will be the LCM? So LCM will be 18 and 24, the LCM will be 72 minus 4 or 68. Okay. So when such a number is divided by 36, you know the remainder will be 32. The remainder will be 32. Okay. So the remainder is 32. Okay. 68, the remainder is 32. Now, what I also want you to see is, again, if you have to look for higher numbers, it is just a multiple of n. So in the smallest one, it's 72n minus 4, ideally. Okay. 72n minus 4. So n in the smallest case is 1, and n can have higher values like we did in the previous problem. When it is higher value also, you will be able to see it is giving you a remainder of 32 only, because 72n is end of the day is completely divisible by 36, whatever the value of n, because 72 is itself divisible by 36. And then you left with the remainder of -4. So when you get a -4 as a remainder with 36, you nothing but the remainder is 32. Okay. So the answer will be 32 for all such values. I took the smallest value and show you, but with all such values, the remainder will remain same, which is 32. So the next one says how many numbers less than 200 leave 4 and 2 as remainder when divided by 6 and 7 respectively. So here you see the gap is not same, because when divided by 6 you get 4, when divided by 7 you get 2. So there is no such formula as such here. So what we need to do, so the number we can say is 6a plus 4, and or the same number is 7b plus 2. So the gap is not same here, not the remainder is not same, so we cannot use any of the previous two formulas that we have seen earlier. So this is the value of n. So both the numbers are equal. So I can say 6a plus 4 is equal to 7b plus 2. Or we can say 7b is equal to nothing but 6a plus 2. Okay. So the smallest value of a which will satisfy this criteria. So 7b, 7 in ones are 7. So that is not possible. 7 twos are 14. So that is possible when a is 2. So when a equal to 2 and b also equal to 2, then it satisfies. Then n is nothing but 16. So this is the smallest value of n that satisfies the criteria. Smallest value. So smallest value of n that satisfies the criteria. Okay. So then the next value of n is nothing but LCM of 6, 7 plus 16. So you got 16. So if you do LCM of 6 and 7, it will be 42 plus 16, which is 58. So 58 will be another one. So we can say 42n plus 16. So yeah, the next value of n is 42 plus 16. The subsequent values of n will be 42n plus 16, where n was 0 in the first case, you got 16, which satisfies the condition. N being 1 will satisfy the condition, and then so on. So the next set of values will always be LCM of 6 into 7, 6 of 6 comma 7 into n plus 16. So then how many values of such will be less than 200? So we know 16. So 42 twos are 84. Then 42 into 3 is 126. 42 into 4 is 168. 42 into 5 is 210. Into 5 is 210, which is more than 200. So these four values. So n equal to 0, 1, 2, 3, 4. These are the 5 values for which are less than 200, and it will give you satisfy the condition. So how many numbers? So n equal, so the answer is 5 such numbers. So when n equal to 0, we got 16. When n equal to 1, we got this, and then the subsequent numbers of n. So this is basically nothing but subsequent values of n. The subsequent values of n is nothing but 42n plus 16. So yeah, so there are 5 such numbers which satisfies this criteria. Next one, a number when successively divided by 9, 7, and 4 gives a remainder of 6, 5, and 2. Okay, there is a formula for it, but let's not go to the formula. Let's see how we can go ahead without that, and then at the end I'll tell you the formula. So a number, when again go back to the successive division concept session where we have very detailedly explained how we do that. But to give you a quick summary, what we can do. So there is a number n, and then you have your divisor, your quotient, and your remainder. So divisor, quotient, and your remainder. So let's say I write divisor as D, easy. Divisor, quotient, and remainder. Okay. Let's see what is happening here. So in the first case, when n is divided by 9, let's say you get a quotient of 1, Q1, and your remainder is 6. Okay. Then the quotient that you got will be divided by 7, because that is meant by successive division. So whatever the quotient you get every time, that is getting divided with the next divisor. So 7, your, let's say your quotient you got Q2 and the divisor as 5. Sorry, the remainder as 5. Then your Q2 becomes your number, and then you divide by 4. Let's say you got Q3 and you got 2 as a remainder. Okay. So let's see if I can find n from here. So I know small. So now I can say my n is nothing but 9 Q1 plus 6 divisor into quotient plus remainder is basically the value. So Q1, I can write it as 7Q2 plus 6, 7Q2 plus 5, and Q2, I can write it as 4Q3 plus 2. I can write it as 4Q3 plus 2. So I can replace Q1 with Q3. I can replace Q1 with Q3. So 7 into 4Q3 plus 2 plus 5. Q2 I just replaced with 4Q3 plus 2. So that is 28Q3 plus 7 to the 14, 14 plus 5, 19. So Q1 is 28Q3 plus 19. So if I have to do for n will become 9. Q1 is 28Q3 plus 19. 9 into 28Q3 plus 19 plus 6. So 928 is how much? 252Q3 plus 919 is 171. Yeah, 171 plus 6, 177. So n, I can say, is 252Q3 plus 177. Okay. So 252Q3 plus 177. Okay. So the least value of n will be 252 into 1 plus 177, or 429. The least value of such number is 429. Okay. Now when you divide, so remainder of 429 by 63, we will get remainder as 56 or 51. Get a remainder of 51. 63 6 see 3 6 18 1. So 378, and then you get a 51 as a remainder, and you will get the same remainder for everywhere. So this is how you can do the successive division. If you want to know the formula of this to do it in one line, but that's a little complicated formula. So that's why I always try to give you a generic understanding of the concept, so that if you get the formula, not sure about the formula, you can still go ahead. But if you want to know the formula, then let me write down the formula. N is D1, D2 into D3 into K. So D1, D2, D3 are nothing but your three divisors that you get here, a 9, 7, and 4. plus D1 into D2R3 plus R2 plus R1. Okay. So R1, R2, R3 are your three remainders. D1, D2, D3 are your three divisors. So D1 into D2, R3 plus R2 plus R1 outside. So this is the formula you can use to get the least values, to get the value of n, and by multiplying k you get such higher values. But yeah, it will give you, this is what you can get. But rather than doing this, you can get n from here also, and you will get something similar. Okay, you can note down the formula. You can use this if you remember. Otherwise, you can use the normal straight approach like we did. Let's go to the next problem. The LCM and HCF of two numbers 16, 38 and 7 respectively. Okay, so let's say the numbers are, let's say if 7 is the HCF, then the number can be 7A and 7B, because 7 has to be the common factor between both of them. So when I write 7A into 7B is 1638 into 7, because we know the product of two numbers is basically product of their LCM and HCF. Okay, so from here we get AB as 1638 divided by 7 much. Okay. 7 2s are 14. 2 3 7 3 are 21, and then 234. AB is your 234, and then they said 7A plus 7B is 217, or we can say 7 into A plus B is 217, or we can say A plus B is 31. So you know A plus B is 31, AB is 234. So these are the two things that we got. Plus B is 31 and AB is 230. Okay, so a little, yeah, from here I can write B is equal to 31 minus A. If I can write B equal to 31 minus A, let me put back in AB. So A into 31 minus A is equal to 234, or we can say 31A minus A square is 234. If I take it on one side, it will become A square minus 31A plus 234 equal to 0. Now 31A, you can break it into 18 and 13, which will be a multiplying both of them will give you 234. So A square minus 18A minus 13A plus 234 equal to 0. So A into A minus 18 into A minus 18 equal to 0. So A minus 13, A minus 18 is equal to 0. So A can be 13 or 18. So B equal to again 18 or 13. Okay. So find the greater of the two. The greater of the two. So the 7A. In the first case, if I consider these two, 7 into 13, 91. 7B, 7 into 18, 126. So the greater of the two is 126. In either way, the greater will be 126. So now you know to apply this LCM HCF. The sum is given, how to get the numbers. Let's go to the last problem for today. It says a natural number when divided by 5 and 9 leaves a remainder of 2 and 3. How many such three-digit number are divisible by 6? So 5 and 9 leaves a remainder of 2 and 3. Again, not a common remainder, not the exact same difference. So can I write n is equal to 5a plus 2, or 9b plus 3? Okay, so both of them will be equal. So doing the same thing, 9b plus 3. So from here I can write 5a is equal to 9b plus 1. So the common thing here will be, a equal to 2, and e equal to 1 gives you n equal to 5 into 2 plus 2 or 9 into 1 plus 3. So the n is 12. So the next set of n, then subsequent values of n will be LCM of 9 and 6 into k plus 12. So this will become 45k plus 12. Okay, 45k plus 12. Now, like example same previous one. Now this is how many 3-digit numbers of such divisible by 6. Now if I do 45k by 12, 45 when k is 1, 45 plus 12 is not divisible by 6. 12 is divisible by 6 always, but 45 is not divisible by 6 when k is 1. If I do k is 2, then 45 into 2, 90, which is divisible by 6. So see, if I break 45, what is there? 45 is basically nothing but 9 into 6, no? So that is 2 3 square. Okay. So 45 does not have 2 in it, right? 45 is nothing but your 3 square into 5. 45 is 3 square into 5. Now, if I do 45 as 3 square into 5, then there is no 2 in it. For 6, I need 1, 2, and 3. So to bring that 2 into this, that has to come from the k. So k has to be a even number in order to become 45k divisible by 6. 12 is always divisible by 6. So there is no doubt there. But for k has to be an even number so that 45 becomes an even number which is divisible by 6. So for k equal to 2, 4, 6, and so on, 45k plus 12 will be divisible by 6, right? So the highest I can think of is k is 20. Then 45 is basically 45 into 20, 900 plus 12, 912. K equal to 22, it will go beyond 3 digit, it will go more than 1000. So k from k equal to 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So there are 10 values. So 10 such values for which the 3-digit number which satisfies the condition when divided by 5 and 9 gives a remainder of 2 and 3 respectively will be divisible by 6. Okay. So that is the case. There are 10 such values. So I hope you understand the certain nuances on how to find out a number when certain remainder or divisibility conditions are given to you along with the remainder, which solve all the different type of problem. Okay. The next session will focus specifically on remainder theorems and some of the last digits kind of a problem session in the upcoming couple of sessions. And then we will wrap the number system completely. But I'll highly recommend to go through all the concept videos that we have covered in number system. Those are very, very useful. Okay. And I hope this session was helpful. Any doubt, please feel free to drop a note in the comment or mail me. Feel free to like, share, subscribe, because that's the primary motivation of creating such PCAT videos for you. And yeah, see you next time. Thank you. Bye.